Okay, so normally on the big ideas stuff, they have these warm-ups. Again, in the videos lately, I haven't been putting them, but this is a good lesson to go ahead and include it. So I would challenge you to go ahead and pause the video and try these. I'm going to slide down to the answers and explain how they got them a little bit, but go ahead and try these if you will. So again, when we're adding up all the interior angles of a quadrilateral, everything should add up to 360. So that's how they would get the answer, is they would set everything equal to 360 on the inside and then solve for the x's individually. For the triangle, we're going to add everything up to 180. And then lastly, we have an isosceles trapezoid over here. So we could have done either fact that the top two are the same and the bottom two are the same and added everything up to 360, or we could have just simply added those two up to 180 degrees because they are consecutive interior on parallel lines. So in this lesson, we're going to talk about inscribed angles in circles instead of, again, we talked about before circumscribed or with the central angle. So these are going to look a little bit different. So we're going to have inscribed angles and inscribed polygons. So we're going to talk about inscribed. What inscribed means is that the angle is on, or the vertex is on the circle itself. Now, when this happens, there's a couple things that are going on and a couple key terms that you'll have to know for your homework. So the inscribed angle is angle B. The intercepted arc is what it's cutting off of the circle on the inside. Okay, and then it says angle B intercepts at arc AC. It says AC subtends angle B, so I mean it's created from angle B. And AC is also created from angle B. So that subtend just means that it's created from that inscribed angle. So kind of our big idea here for today is that if we have an inscribed angle, the measure of the arc is half the measure of the inscribed angle. So if we know this angle, we know this arc is double that, basically. So in our example here, again, some things that we always kind of want to watch for are diameters. So when we have a diameter, we know that the entirety of this is going to be 180 degrees. That does not change. So when I want to find angle T here, I'm going to have to take 180 and I'm going to have to subtract it to find this arc if I want to find this arc. But all they're asking me for is that angle. So all I need to do is take 48 and divide it by 2. So 48 over 2 is equal to 24. Okay, and then the measure of arc QR, again, we need to take the fact that, first of all, that 50 is going to create 100 degrees here. And then we have a diameter, so the leftover QR over here has to be 80 degrees. So we really pay attention to what we're given throughout the course of the problem. Okay, so find the measure of RS. So they want us to find this arc right here. And then they want us to find STR. We'll do that in another color. So STR is this angle right here. And then it says, what do you notice? So again, arc RS or SR is created here, if we'll notice, by this angle right there. So if I want to find that arc, I need to double 31, which is 62 degrees. Now, if we'll notice, this angle is also creating this arc. So this angle here is also creating that same arc. And so what they're trying to get us to realize here is if we have two angles creating the same arc, those two angles have to have the same measure. So the measure of angle T, or STR, is the same as the measure of angle RUS because they create the same arc. So that's our next theorem. It's just saying if we have two angles that create the same arc, those angles that are inscribed inside the circle have to be congruent. So again, it's kind of alluding to that once again in this problem. We have this arc here being created by angle E, or HEG, at 75 degrees, and then they want us to find this angle right here. Well, it has to be 75 degrees. They're creating the same arc. Pretty straightforward. So again, take some time, find the measure of the red angle or the red arc that is inscribed inside the circle or being created by the angle inscribed. So an inscribed polygon is a polygon who is in the circle and all the vertices are going to touch on the circle. So the image here is an inscribed pentagon and a circumscribed circle. So we have a couple of properties, and again, this is no different than what we've seen before. Again, don't write everything down up there. This is pretty sufficient. Down here in the box, we'll box this in. So it says the measure of angle ABC is 90 degrees if and only if AC is a diameter. So we have to realize that, again, if a diameter is created, that means that this angle is creating the whole half of the circle over there. So if this arc, if this dotted arc over here is 180 degrees, we know half that has to be 90, is basically all it's saying. The quadrilateral in a circle, again, it's saying that if all those vertices lie on the circle, that the sum of them have to be equal to 180 degrees. Again, well, not the sum of them, sorry, the sum of them is 360, but they're saying the sum of any pair have to be 180. Shh, I'm doing a video, honey, not right now. Okay, so in this one, we can see that we have 2x at our right angle, so we just say 2x is equal to 90 degrees. We divide by our 2. We get x is equal to 45 degrees. Okay, and in our polygon, again, we are just going to take the fact that we have 2 consecutive angles in there that add up to 200, and then the other 2 have to add up to 360 with the whole thing. So again, if we look at this up above, it's saying the measure of D and F, these have to be congruent to these, which also have to be congruent to 180. So if I look at the opposite angles, they have to be supplementary. So Z plus 100, or excuse me, Z has to equal 100 for those to be supplementary. I keep wanting to write 180. Z has to equal 100, and Y has to equal 60 for those to be supplementary. So again, the opposite angles have to be supplementary inside that circle. Again, here's an opportunity for bonus if you want to construct this in your notes. I only had a couple kids take advantage of the other one so far. Again, if you're someone who's trying to get some extra points here towards the end of the year, these are a good way to do it. So make sure you pause and get these other 3 problems in your notes for section 10.4. There's only 6 problems total for the monitoring progress in this lesson. Other than that, again, make sure you know what an inscribed angle is, what an inscribed polygon is, and again, just briefly go look at those theorems up above if you need to. But these should be pretty straightforward. Make sure you guys ask if you need any help. Thanks. Have a great day.